Hey, what's going on, guys? CMK here. In this video we're going to be programming Marrow walking across the LCD screen on CMK computer. But before we start, let me actually demonstrate how the end result of what we're supposed to be developing in this tutorial is going to look like. So I will now compile and run the program that I've prepared already. Copy, and then I need the serial monitor. Paste, and now I need to initialize CMK computer to receive the data, and here we go. And now already you should see how Marrow is actually walking across the LCD screen. So it consists of four characters basically, and the body part is changing, hence the animation, and the head part is always kind of like the same, always the same pattern there, right? So we'll now create a program using CMK assembly. Step by step, we'll encode the characters like this user-defined graphics, and then we'll write some code to actually make it moving across the screen. So if you're interested, without further ado, let's actually start. Okay, so the LCD display allows you to add up to 8 user-defined characters, also known as user-defined graphics, and each character consists of 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8 pixels, which can be manipulated by setting the corresponding bits to ones to make this kind of white, and those bits left as zeros would leave the pixels being turned off. That's pretty much all about it. And you might be wondering why it's only 5, not 8. Well, that's because the first 3 bits are used to encode the index of the character that we're supposed to be creating manually in our program. And here I've created this template, so it would be easier for you to actually kind of like draw the sprites by hands. And then it would be much easier to encode the sprites. But obviously I've already prepared a couple of sprites introducing Marrow that we would be using, those sprites that I've just been demonstrating. So let's have a look at those, and we're going to be using these sprites in order to encode them into our program. So here is the first frame, and here is the second frame. So like step, and step, 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 step. So what our program is going to be doing, you're going to be just changing these to these bottom characters, so up to 4 characters for entire Marrow, and these 2 characters in the bottom would get changed. And also we're going to be scrolling the screen to the right in order to mimic Marrow walking across the LCD screen. Okay, so now, well, no, actually, yeah, I actually need this, and I'll probably put it here, and yeah, I just want to make it always on top as well, and my camera is always on top as well. So now here we're going to be encoding the bytes that we can see, and yeah, probably sorry guys, I just get rid of the camera for a while because I really want you to focus on this picture. So let's define the labels where we're going to be storing the bytes for our characters. So we'll start by defining the first one. So let's say Marrow. Yeah, here I have a file called marrow.asm. It's in the folder where the assembler.py is available. So if you didn't watch the previous videos on how to download the CMK computer source code and how to load the programs, how to assemble, feel free to have a look at that. So this tutorial will already assume that you know how to do that. Okay, so Marrow head and the left part. So we're going to be encoding this kind of character. And first, yeah, before actually defining the bytes, 1, 2, 3, 4, 5. I just want to have the pattern of 5 by 1, 2, 3, 4, 5, 6, 7, 8. And also just want to provide the patterns for all we need. So Marrow head left, Marrow head right. Now Marrow body left 1, and here marrow body body right 1, and also here just grab these guys, and this would be marrow body left 2 for the second frame and body right 2 for the second frame as well. Okay, so now let's encode this one. So I replace the empty squares by zeros, and those being highlighted by ones. So very simple. So here we have all 5 zeros, 5 zeros. Here we have 1. So that's what I'm going for. So 1, then 2, like 1, 1, 1, 1, and then like this, like this, like this, like this, and like this. So let's verify. So I hope it's clear. I'm just replacing this this highlighted pixels by ones. So these are the corresponding bits. We'll now convert them to the normal bytes. So just a bit of a patience. All right, and now the next one. So starting from here and like this. Okay, and the mustache of marrow, the most important part. So eyes, the mustache. Okay. Yeah, this should be the case. And yeah, I would be just checking myself, because if I just make something wrong, it would look weird. So just to make sure that everything works properly, I would be encoding them one by one, then printing the screen to make sure that I did everything properly. And now we need to add up to 3 bytes in front. And those 3 bytes would be serving to save the index of the user-defined character. And now also let's split the nibbles. So it would be easier to manually convert binary to hexadecimal, because CMK assembly relies entirely on hexadecimal numbering system, just like the 6502 assembly, by the way. So here I just defined the byte in hexadecimal, so 00, right? And let's put it somewhere here, right? Then byte 0x, still 00, no bits. All right, and this is gonna be 01, byte 0x01. Okay, and now this one is gonna be byte 0x03, right? Byte 0x03 as well. Okay, and byte 0x05. Okay, it's a bit boring, but actually it's not when you're doing this on your own. 05, it's really like creating user-defined graphics. It was one of the favorite things I can do with my CMK computer. 0x06. All right, so this is already good enough to actually try encoding the character. Okay, so it should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and I just minimized this one. Let me restore the camera back. So at the very beginning of the program, let's just define the start label, and here I want to say LPC, which stands for load program counter, which is literally an unconditional jump to let's say create graphics. Create graphics. Oh, what have I done? Graphics, right? I hope I've spelled this properly. Create graphics, copy, and then down below here, so we'll end the program for now. As far as we don't have a loop, we need to end the program with a 0 terminating byte in order to avoid any possible errors. Okay, just I just want to literally have the same indentation Okay. Yeah, this should be just fine. So for now, this is just a 0 terminating byte. And now, so just, well, I obviously remember this sort of a thing by heart, but just to, for those of you who's not familiar with the CMK assembly yet, I want to provide the source of documentation that I've created. So here we have the operation codes, assembly mnemonics, and we need the UDG, which stands for user-defined graphics, and it assumes that A equals to the character ID from 0 to 7, while B points to byte array where we have our encoded character. So let's start by initializing the pointer to the byte array. So I can simply say LDI, and now this marrow head left, copy, and the assembler will replace this label with the address of marrow head left. And we want to transfer this to the B register, so just provide the commentaries on the run. So load address of marrow head left to A register. Yeah, you don't see this, so let me, okay, to A register, and transfer it to B register, to init the data pointer. All right, and then LDI 0x00, and here we want to init index of 0 for the first sprite, for, let's say, for marrow head left sprite. Okay, and then we can simply say UDG. This will create the user-defined character, so create user-defined character. And then if we want to flash it onto the screen, we need to use the SPR, which stands for sprite, and give a parameter, which the byte that represents the index of which sprite in particular do we want to draw on the screen. So SPR 0x00, and here we want to draw marrow head left to on LCD screen. That's pretty much all about it. So now, do I have, yeah, so here is the terminal being opened in the current working directory, and by simply saying Python 3 assembler.py and mario.asm, I'm assembling the program, and here are the program bytes which I can copy. And now I'm going to the online simulator provided by TINKERCAD, which is available on my GitHub. So here we can just maximize the input and output like this, for instance. All right, and start simulation to start the CMK computer. And now to start listening to incoming bytes, I'm entering the command fffd, which has been covered in the previous videos within this series, and just pasting the bytes and sending them. And now if I did everything properly here, it should print the very first, after I say FFFF, which stands for run, it should print the very first. Yeah, and this is the part of the marrow head, and this kind of part is printed right over in here, which is exactly what we wanted to have. So far so good. And now let's encode the second one. Okay, so yeah, now we're gonna be working with this one. So let's start by, yeah, so we already have that. So byte 0x00, all right, same here. Copy. Okay. Well, actually, I can just paste them all here, because anyway, I will need that by keyword. All right. Okay. Okay, great. So the next thing is to encode them. So yeah, and also here add three zeros in front and split the nibbles for easier encoding to hexadecimal. So here we have 1, 8. Okay. Here we have 1F. Okay. Here we have 0, 8. All right. Here we have 0, 8 as well. Okay. 0, 4 here. Okay. And 0F right over in here. And already we should be able to draw this part of Mario head. So let's duplicate the code for let me just get rid of this one. So let's duplicate the code here. Okay, so Mario head right in this case. So this is another label, another address. So Mario head right, and everywhere it's used, just replace. Okay, and the index is going to be 1, and here the index of 1 for Mario head right sprite, user defined graphics, and here copy Mario head right on the screen. And as far as this one has the index of 1, this is the exact index that we're going to be using here. So if now did everything properly, after assemble and run, we should already see let's just make the hardware reset here. We should already see the entire head of Mario, right? So FFFD and send, and it, by the way, it works faster on the real hardware, which I've been mentioning many times before. And we have the Mario head, which should be the same as what we see here. Let me just verify this quickly. Yeah, it seems like to be exactly what we want. Well, it might be a bit arguable whether it really looks like Mario or not, but yeah, you see, like, the pattern actually matches, so this is exactly what we wanted to have, right? Well, I really hope that you guys are better artists compared to me, because I've been drawing this on my own. Well, obviously I have been referencing the existing Mario sprites, but the eventual version, I've made that on my own, really. So yeah, now let's encode this part actually. So and this stands for Mario body left. Okay, so here all ones apart from this one. The first, here all ones, here all ones like this, and here 2. Okay, then 2 spaces, then 1, then 1, 2, 3, 1, 2, 3, and finally this one. So is this the case? Yeah, just trying to match the pattern. Well, this should be the case. So 1, 2, 3, just add in this zeros, 3 bits representing the index internally. All this happens internally within the LCD on its own, and obviously my assembly is just wrapping around the LCD liquid crystal library of Arduino itself. Okay, so 0F here. Okay, here is 1F. Okay, here we have 1E. Okay, here we have 1/8. All right. You really need to be careful here, because if you just if you translate this binary to hexadecimal the wrong way, the bits would not match. So you really need to be very precise here and accurate. So 0, 1, all right, 0, 7, yeah, and 0, 7 here as well, and 0, 4. Okay, and yeah, here we go. Now let's encode. Well, now the things are gonna be a little bit more interesting. So if we just type, if we print the character right next, without changing the position of the cursor, it's not going to be a good idea, because the body of the arrow would be this next to cell. So we need to put the cursor right over in here, down here. So let's put the cursor first. I can simply say LDI 0x001 and transfer it to B. So here we want to load 0x01 to a register and transfer it to B register. Transfer it to B register to initialize cursor row. So cursor row 2, cursors, let's say second row. Let's say to put cursor to the second row, and then LDI 0x00. So load 0x00 to a register to initialize, to put cursor to the first column of the LCD display. So if we have a look how the so-called pause instruction works, it assumes that A equals to the column while B holds the row where to put the cursor. Then we can call this pause instruction, and the cursor would get set appropriately, respectively. So pause here, we literally say set cursor at 0, 1. So this is column and this is the row. Okay. And now we can actually print the left side of Mario's body. So Mario body left 1, and copy. Is this body Mario body left 1? Mario body left 1. Paste here. Paste here. This is going to be index of 2. Let me make sure that, index 0, 1, index of 2. And actually, hold on a sec. So first, so these two should be placed. Guys, I'm sorry, for a bit of misleading. So we can initiate we can create the graphics at first, and then this part for rendering the characters to screen, it would be taken into the separate loop, infinite loop later on. So I just want to say that first we draw this first to this two first sprites, and after we want to print copy. Well, this one is not available yet. This is gonna be 2, and this is gonna be Mario body left 1 on LCD screen. So let's see what we got. Okay, and I want to reset the computer. So now there should be up to 3 characters, three sprites, so the head and the left part of Mario's body. So let's have a look if it works. Okay. Yeah, and it seems like it works exactly as expected. So yeah, we have the leg and the left part of the body. So far so good. So now we can already go and implement this very last part, and then we'll go to the next to this image. So yeah, okay, so far so good. So yeah, let's go and encode Mario body right 1. So this is gonna be 1 1 1 1 1 here, here, and here, here, and here. Is this correct? Yeah, just trying to verify the pattern. Yeah, this should be fine. So adding the 3 zeros, the bits holding the index of the user-defined character, and splitting the nibbles for easier conversion to hexadecimal. And let's go. So this is gonna be 1 8. This is gonna be 1 0. This is gonna be 0 8. 1 8. 0 8 0 8 1 0 1 8. Okay, so should do the trick here. Should do the trick. And now we'll print this one as well. Okay. Okay. Okay, great. So now I want to find Mario body right 1, and this is gonna be index of 3, paste, and index of 3. And here, just right after the left part of the body, we want to draw the right part of the body. And let's have a look if we have the whole Mario now appearing on screen. This is gonna be fascinating. Okay, so loading the data and send. And here we go. Okay, so far so good. So it seems like exactly what we're supposed to have. So let's verify things. Yeah, it really looks similar. Really looks similar here. Yeah, so it's pretty recognizable. Okay, so now we go to this part. So we need 2 more custom characters to be encoded, created, and then we'll start coding our little animation. Okay, so yeah, so let's go here, and what I want to have is, yeah, this one. So now we're going to be encoding this part. So we've done this too. Now we're going to be doing this, guys. So Mario body left 1. And here we go. So 1 1 1 1, all ones, 3 ones here, 1 here, 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 all ones here, and 2 ones here. So far so good. So 0 0 0, and okay, splitting the nibbles and encoding. So 0F, 1F, 0E, 08, 01, 0, 8, 1F, 0C. Yeah, this should be the case, so let's see if it works. Well, and yeah, actually, let's go straight ahead and encoding the last sprite as well. Just probably this is going to be a little bit faster. Well, just hopefully it's going to be a little bit faster. All right, so okay, now this one, so we have 1, 2, 3, 1, 2, 1, 2, like this, 1, 2, 3, all ones, 1, 2, is this the case really? 1, 2, 5, 3, 1, 0, 1, 1, 0. Yeah, this should be the case. All right. I don't know how about you guys, but for me personally, this is really kind of like one of the most, as I've been mentioning before, one of the most exciting parts of development. Okay, so 1C, 1, 8, 0, 8, 0B, 0, 7, 1F, and 0, 3, and 0, 0. Should be the case. If we did miss something, that might be fixed easily, because we see that something goes wrong on the screen. We can always go back and check which byte has been set up wrong or encoded wrong, and then we can fix it. And that's pretty much all about it. Okay, yeah, so now let's encode these two. Now let's encode these two guys here. So I want 2 and 2, and here is what would be index 4, index 5. This is going to be index 4, this is going to be index 5, and don't forget to change the label names in the commentaries, like this, like this. Okay, and yeah, just before anything else, I want to replace this 2 and 3 by 4 and 5, just to verify the fact that we actually did everything properly. If we did everything properly, and then we'll go animating this tiny little marrow character. So let's have a look if the sprites are working properly. Okay. And here we go. So let's verify let's verify. So does it look hold on a sec, it doesn't look exactly the same. Yeah, well, even though this might be on the cards as well, it looks quite pretty nice still. Yeah, but actually it has a little bit of an issue, so it's not exact. So here it should be 1 and here it should be 0, but I don't know, guys. I like this marrow version as well. Well, okay, just for those purists, let's actually change this bit just to show you how easily this can be done. So this should be here. Yeah, but hold on a sec. Did I 1 1 0 1 and here is 0 1 1. Yeah. Hold on a sec. Maybe it's not B, or hold on a sec. I just can't get. Okay, guys. Yeah. Hold on a sec. So 0 1 1 0 1. Zero 1 1 0 1. So did I convert this round to hexadecimal? So 2 sorry 1. So this is C. Oh, this should be D. Yeah, it's not B, it's D. Okay. Yeah, so a little bit of an accuracy. Yeah, that's because I was a little bit in a hurry. Yeah, now it looks exactly the same. So yeah, let's verify. Yeah, now it looks exactly the same. Yeah, so far so good. Okay, so we don't need this Marrow sprite as an image anymore. And from now on, we are ready to start the animation and to make Marrow walking. So yeah, let's start by providing the animation. And as far as this is not a game or something, just a demo, we'll go for a very kind of simple way of doing things. And yeah, but yeah, I also need to add a bit more, just to add some commentaries. Hold on, guys. I just add some commentaries very quickly. Yeah, so here we have the should have done this before. So we have the program start. Here we want to jump to create graphics label. Yeah, maybe just like this is just fine. And this is left part of Mario's head, and this is the right part, or let's say yeah, okay, so this is the right part of Mario's head, and the left part of Mario's body standing, and there would be body stepping. So here is the right part of Mario's body standing, and here we have the left part of Mario's body stepping, and the right part, and the right part of Mario's body stepping. Okay, so here we want to create user-defined graphics. Yeah, graphics, sprites, characters, call them however you want. Okay, and I no longer need the spaces because I'm not going to be touching this great graphics label any longer. And here we will jump into the, let's call it walk, or Mario walk. Okay, and here we no longer need the terminating by the way. So here, as far as we're gonna be, well, I just want to as far as we're going to be printing this sequentially to mimic how walks along, we also need to adjust the cursor position before we draw in the head, because when we're going to be looping back, that would be essential. So here, just exactly the same, but we start from the row, setting cursor at row 0 and 0. So cursor at 0, 0, print in the head, cursor at 0, 1, print in the body, and then okay, then we want to have a delay, delay 0xFF. Well, actually, on the real hardware, it's better to have the delay of like this, which I will do because it's really seems to be working on the real hardware rather than in emulator. But anyway, so this is 255 milliseconds delay. Copy and paste. Okay. You know, we need to draw. Now we need to set the cursor back to the beginning of the line, and just so here we are drawing the next step 4 and 5, and here I just restore to 2 and 3. And finally, a low program counter to Mario walk. Repeat, like repeat Mario walk loop. This is going to be the infinite loop. And now if I did everything properly, it should just be animating the frames. So it's kind of like showing one and then showing the other. So just displaying the Mario body, 2 different sprites. Like, well, you'll now see what am I talking about if it works, hopefully. Okay, and let's have a look. Oh yeah, it just, yeah, not exactly, it just hold on a sec, it prints the Mario head in the next. No, it's not exactly what I've been thinking about. Right, so for some reason, yeah, I'm drawing the Mario head here, which shouldn't be the case. So yeah, let me just split the code. So here, initializing the cursor at 0, 0, and printing the Mario head. Then go into the next row and print in the body that stands. Then the delay. Then going back exactly like it was here. So this is the duplicate, and yeah, now this should in theory be drawing the animation properly. Let's have a look. Okay. Yeah, it doesn't draw this any longer, but also for some reason, what am I doing wrong? I'm just wondering. It should really be is the delay too long? Yeah, so in the emulator, the delay behaves a little bit different. So, but yeah, I just forgot to put the delay here as well. And yeah, now this should be Now this should be working properly. Okay. Unfortunately, it's slow as hell in the emulator. On the real hardware, it just uploads instantly all the time. Yeah, and now finally we have Mario that walks, but it doesn't move, but it kind of walks, which is already a great thing. Now, all you need to do in order to make it walk, well, at least it's not the best ever solution for a game, but it's good enough solution for a demo like this. We have a very handy instruction in CodeMonkeyKing's computer, which is called scroll display to the right, SDR, and where is the SDR? SDR, where are you? SDR scrolls, contents, and the cursor, which is also important. It's not mentioned here, but that's mentioned in the Liquid Crystal library for Arduino. So scroll display right is the single instruction that would allow us to make this Mario walking along the LCD screen. So if I just say SDR, so scroll display to the display and cursor, by the way, and cursor to the right to mimic Mario walk. Okay, and okay, but there would be one more tiny little issue with this kind of approach, because the screen buffer is bigger than just the content of the screen, obviously, because it kind of scrolls. So we'll need to make one more little hack here to avoid waiting for ages, until Mario would be walking through the dark side of the moon. Okay, I'm just kidding. Yeah, so here we go. I meant to say FFFD. I just was talking and said FFFF twice. Okay, now FFFF to run. And now the Mario should walk. And it does. So it does walk, which is really awesome. Okay, so yeah, it might be laggy, but now here is the issue that I've been talking about here. So once it goes beyond the edge of the screen, it would now take, I don't know, probably around 16 iterations more, because we have the 16 calls here. So one day he would appear here. Well, I can talk until this happens, but again, like, this is not the exact behavior that we want to achieve. So we really want Mario appearing here just right when he leaves. So you see, like, yeah, he is there. He didn't gone anywhere, and yeah, for some reason I don't even know, guys. Yeah, probably this is the problem of maybe this is the problem of the simulator. I don't know. It works perfectly well on the real hardware. It actually keeps walking, but here it stuck for some reason. I don't know. Do we? No, we are still in the infinite loop. But yeah, unfortunately, well, the simulator doesn't represent what happens with the real hardware. Or maybe I just did some minor mistake here. But anyway, the way to solve this is the following. So we can simply do the next thing. So we can just create the count variable, and here let's say byte 0x00, for instance, and we have a label. I don't know how to call it, so let's call it reset Mario. I don't know, maybe it's too brutal, but I think we can go for this. And this is what we're gonna be doing in our main loop. So I want to so first, yeah, just to make sure, I want to reset both the B registers and the A register, LDA, to avoid having any offsets for the next instruction. We're going to be using LDA count, which is going to be reading the value at the count. So here I just want to reset register A, reset offset in register B, and well, actually, yeah, we don't need this even. And here load the value at count variable plus 0 offset in B register to A register. All right. And here I want to compare, well, let's start by comparing with 8. And now this is the conditional jump. So if count is equal to A, we're going to jump to reset Mario, like this. And here want to clear the screen and load program counter to Mario walk. Yeah, and that's pretty much all about it. Mario walk. So yeah, let me just make sure that I did everything properly. So now it should go to the half of the screen, send, and then appearing. Oh, I shouldn't be doing this. Yeah, I just send first. Well, this is okay on a simulator, but on the real hardware, you really need to first enable computer to listen to the data and only then send. So another important thing to consider. Okay, so yeah, here it doesn't work for sometimes as well. Yeah, let's reset things. That's because I've missed the order. So FFFD, paste, send, and now it should go up to the center and then hopefully start walking from the very beginning. So let's see if it does. Okay. And whoa. It's not exactly what I meant to do here. This is strange. Did I forget to? Maybe I just forgot to compile, to recompile. I'm sorry guys, I don't know why did this happen, so probably I just forgot to recompile. Should drop here. Again, I'm developing on the real hardware and I have no idea why it works, why it behaves this way on the simulator. So hold on a sec, I just need to check this out. Okay, yeah, I'm just an idiot. That was the reason. So we obviously need to say increment memory. Because, yeah, so just let me introduce you to this function. So INM stands for increment memory. It takes the address of where to increment the memory. So, and here the count. So by doing this, count would be 1, 2, 3, 4, etc. So yeah, it's not the matter of the emulator. It's just code monkey keying. Yeah, forgot to increment the variable. That was the reason. Yeah, now hopefully, yeah, probably just again click too early. Maybe not. Hope for the best. Okay, so at least now, Mario, would you please disappear in the center of the screen? Okay, yeah, thank you, man. Yeah, he disappears, but for some reason, well, I'm a bit confused by why it doesn't appear next. So as far as I'm clearing the screen, okay. Yeah, sure. Obviously, I need to reset this count because I just didn't reset the count. So if I just say LDA 0x00 and then STA to the count, so we still have B register equals to 0, we didn't change it, so yeah, now this should actually do the trick. So yeah, I just forgot to reset the counter, so let's try again. Let's make sure we got the updated code. Okay. And now I really hope that after disappearing the center of the screen, he should appear in the beginning and continue this as a kind of infinite loop. And why is it so laggy? Okay. Okay guys, sorry, obviously not LDA but LDI, so we need to load the immediate data. Yeah, probably I'm tired today. And so many errors. Yeah, I was loading the value from the address instead of loading the immediate data. That was the problem. And now really hope it will finally work. Yeah, exactly what we wanted to have, but we don't want him to jump from the center of the screen, so we need to let him go until the end of the screen, and this can simply be done by setting the, say, like this is the trial and error value I came up with. So it's 17, yeah, 17 in decimal, right? I guess this should be 17. So F is 15, 10, 16, 11, and 17. Yeah, so make sure it just goes off the screen, and then the next step it just appears. Okay, so now let me add the commentaries here, and we're done. So just before the final demonstration, so let's say if Mario went off the screen, let's say did Mario went off the screen? If so, place him into the starting point. Okay, so here we want to increment count variable by 1. All right, so we don't need spaces any longer. Yeah, and here, so variable holding the value of how far Mario walked since start. Yeah, since start of the loop. Walked, let's say, from left to right. Let's just say from left to right. So init counter to 0. Here we actually want to place Mario. So this is the label to place Mario to the beginning, to the left part of the screen. So we reset a register, and here we reset counter with the value of a register. and the B offset is 0 because we didn't change that here. We just clear the LCD display, and here continue main Mario walk loop, and we are done here, I believe. Yeah, so let's go for hopefully for the very last demonstration. So stop the simulation and start again. And I hold my breath, and let's have a look if it actually works as expected. So now Mario should walk across the screen until the very end of the screen, then hide there, and after he hides here, he should appear back in the very beginning of the screen. And now this should happen, and here we go. And this should be done in an infinite loop. So I just want to watch at least one more iteration just to make sure it doesn't stuck anywhere or something. Okay, and yeah, so it seems like it's working. Yeah, it's yeah, for some reason simulator is a bit laggy, and again, like on the real hardware it works just like a charm. So something that you've seen in the beginning of this video. So yeah, well, I think this is good enough. And we can stop at this point. Okay, so as you can see now that CMK computer is really kind of powerful enough to create graphics on the LCD screen. I really hope you've enjoyed this tutorial. And I don't know how about you guys, but me personally, I really enjoy coding in this CMK assembly that I've created, and it really feels like 652 assembly, but even easier. It only has 40 instructions, so feel free to have a look at the playlist, listen to tutorials on how to code in this assembly, how to code the Comac against computer in general, and feel free to try to write your own games for CMK computer on your own. So this is it from my side. Again, thanks for watching. Until the next time, and take care.